Hi. In the part 1 video of KNN, we are discussed about the some basics about the KNN and failure cases of the KNN. That means the when the data is look like that, it's not good to apply the KNN. And in the part 2, we are discussed part 2 video. Sorry. In the part 2 video, we are discussed about the hyperparameter K and how we can find the K value by using the cross validation technique. Those are the things we are discussed in the previous video. In this video, we will discuss some disadvantages are there for KNN, and to avoid those disadvantages, we are using some tuning technique. That means we are improved some techniques. We added some extra approaches to the KNN. By this way, we can resolve those issues, those disadvantages. Let's see going to that one. For that, to explain that, then let's go with an example. We have two classification data. One is positive class, another is negative class. Let us consider this is a positive class and this one is a negative class in the 2D space. And a query point XQ is given. Okay. And let's consider this is the query point. This is the XQ. Now we will find the and also consider k is 5 and it's a odd value for suppose now. By this way we will find the nearest 5 points. Here the nearest 5 points we can observe. These 3 points are close points and these 2 from the native class. By using the majority based approach, here we have 3 points are positive points and 2 are negative. By this way we will classify XQ as positive class. But it is not good to classify the query point as positive class because there is a 2 negative points also there. That means 2 negative class points also there. To make that confusion, we can use the probabilistic approach. By using the probabilistic approach, we will get the probability of given xk that belongs to positive class. How much? Here the positive points are 3 and total points are 5. And by this way, the probability of xq belongs to positive is 3 by 5. Similarly, the probability of belongs to negative class is 2 by 5. By this way, we will get some reason also. Why we classify this point as positive class. For that reason, we will tell the probabilities belongs to 3 by 5. That's why I was classified this query point as positive class. But one more thing here we can observe that here the query point is very close to these negative points, but we are classified this query point as a positive class, even though it is very close to the negative points. To avoid this problem, we are going to use the weighted KNN. In the weighted KNN approach, we will give the weights for every point with the query point based on the distance. For suppose the distance is more, then the weight is going to be less. The distance is less, weight is more. That means weight is inversely proportional to the distance. Let's consider like this: weight is equal to 1 by distance. By this way, when we sum the weights of these two query points, we will get more. And compared to these weights, we will get more compared to summing the weights of these 3 points. By this way, we will classify the query point is a negative class here. It makes little sense about the query point. Instead of the majority based approach, probability approach gives little sense about that one. And By using the weighted KNN, it more improve the sense. This is the one disadvantage we can avoid by using the probabilistic and weighted KNN approach. Let's see one more disadvantage, that is the time complexity. And one more disadvantage we have with KNN is time complexity, because for example we have the query point XQ, and we have to find the distance from every point in the data. Let's consider we have n number of points in the data, training data. We have to find the distance from every point to the query point, and we will, based on the distance, we will get the short k number of points. Okay, by this way we will get the order of n is the time complexity. To reduce the time we are going to use the KD tree approach. The KD tree is inspired from the binary search tree algorithm. It's one of the searching algorithm. If we want to find any element in a list or array, we are going to use the binary search tree algorithm. Okay, it's a tree based algorithm. Like we will have the branches to the things. By this way we will get, for suppose we have a list of values are there. Initially we will sort those values and we will take middle one, and if the value of the search value, let's like L, see the search value, if it is less than this one we will do once again this split. If it is greater than, we will take this list and we will split that one, and we'll check like that. That is the binary search tree approach. And yeah, and also we are going to create we will create a space to the every point in the data. By this way, by using the access parallel lines, by this way we can reduce the time complexity. Let us see some visualization thing, some intuition about the KD tree to get more understanding about the KD tree approach. Let us consider these are the data points in the 2D space. This is, let's consider 2D space, x-axis and y-axis. And the number of points here, let's consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points are there. Now for these points, this is the 2D space and these are the points. For every point here we are going to create a space by using the access parallel lines. We will start with how we are going to get those things. Let's see in this video. For this we will start create the access parallel lines with the x-axis. For that we are going to get the median point. With median point we are going to find we will create the access parallel line. Here we have 10 points, and the median point will be here. Median value is, it will be lies here only. And yeah, now we will create a access parallel line to the x-axis. And now we will go with the y-axis. We alternatively do this one. First we will started with x-axis, then we will create with y-axis, and then we will come to the x-axis like that. Here we have 5 points, and the median point is going to be 2. This point, because here is 2 points, here is 2 points. This point is going to the median point, and the median point, the line passes through the median point. And similarly here also, this point going to the median. Let us consider these are there. Here also we have y-axis, and similarly y-axis is completed. Now let's go with the x-axis. Here we have 2 points, and the median is going to be, median value is like this, and here also there is 2 points, the median is going to be here. Similarly, the median of these 2 points is going to be here. And similarly, the median of these 2 points is going to be here. And by this way, we have created the axis parallel lines to the data that we have. By creating the axis parallel lines, we have created a space for every point in the data. But for some points, we don't have space. We will consider generally those points belongs to upper. Now, let's consider a quarry point x cube is given. Instead of there, let's consider somewhere other the quarry point. Now we will find the distance from this quarry point, the point which is located in this region. This is the point which is located in this region. Let's consider this distance is d. Now we will plot a circle with d is the radius and the center point is going to be x cube. By this way, we will get the this is the circle we will get because it is in 2D space. If it is in higher dimension, we will call it as hypersphere. Now, this line is going to touching this space, and I will use different color. It's touching this place, and this plane, this place, and this place. We have 4 spaces it is touching, and we will find the distance from the points which are in this region, okay, with this quarry point. Now we will find the distance from this quarry point to this point, 7th point, and also 6th point, because we will consider generally this belongs to upper region, and also with this the 3rd point, and also with 2nd point, and also with 5th point. Here we can observe one thing in the generally by using for the x cube quarry point, we find the distance from every point in the data n. But here we are not going to find the distance from every point in the data. We are just find the only 7 points here. Here is 10 points. Here only find the 7 points. By this way, we have hundreds of points at the time. There is a more time we can save by using this approach. Now, here the time complexity is going to be odd log of n. It's the time complexity. It is the best case. The worst case scenario is order of n is the time complexity. So order of log n is the best case, and the worst case is this order of n. This is the intuition about the KNN. In the next video, we will discuss about the low quality sensitive hashing approach.